We have solved one-step equations and we have solved multi-step equations. But on all the ones we've done thus far, the variable has only been on one side of the equation or the other. Could have been on the left side or the right side, but so far it's never been on both. So that's what we're going to work on today, is what to do or how to solve an equation that has variables on both sides. Now, the good news is this sentence right here. This requires just one additional step of getting the variable on one side only. So let me cover this up. I think it makes a little more sense if I've covered as we go. So if we start with this equation, 4x minus 1 equals 2x plus 7. So again, what's different about this from our other ones we've done is there's an x on the left and on the right side. But it only requires one extra step. We want to combine those two variables. So to do that, I'm going to subtract 2x from both sides. So by subtracting 2x over here, that'll cancel that out, leaving just 7 on the right side. 4x minus 2x is 2x. So now that we've gotten the variables together to be on one side, it's just like the multi-step equation we did before. We'd add 1 to both sides, it gives us 2x equals 8, and then we divide both sides by 2, and that would give us x equals 4. So it's really no different from the multi-step equations, except that that first step does require us to combine the variables by moving one over to the other side. And you can go either direction. We could have subtracted 4x from both sides and put the variable on that side. It doesn't matter. You can get the right answer either way. I'll talk more about checking solutions later in this lesson, but just to show you how you check it in this original problem, checking your solution just means taking the answer you got and plugging it back into the original equation. So you can see I had 4 times x, so I plug in 4 times 4 minus 1, and then 2 times x, so 2 times 4 plus 7. From there, you simplify both sides and see if they match. 4 times 4 is 16. 16 minus 1 is 15. 2 times 4 is 8. 8 plus 7 is 15. So they worked out correctly. So that shows us we did get the right answer when we got x equals 4. Okay, so on number 1, first thing we want to do is combine the variables. And you can do it either way. You can subtract 9x from both sides, or you can subtract 3x from both sides. You can get the right answer either way. I'm going to choose to subtract 3x from both sides. 9x minus 3x is 6x. I just keep the minus 12. And don't just stop there, because it's like, oh, that side just canceled out. Well, that's true, but there's still another side of the equation, because 3x minus 3x equals 0. So you can't just drop one side of the equation. It can become 0, but you can't just stop writing it. Now we'll add 12 to both sides. Then we'll divide both sides by 6. So we get x equals 2. Okay, now this doesn't happen often, but occasionally, before you start solving and moving stuff from one side to the other, there may be some things you can simplify on just one side or the other. And here's what I mean. If I look at just the left side of the equation, 8x minus 12, there's nothing I can do to simplify that because they are not like terms. 8x has an x, 12 does not. But on this side, they are two like terms. I can combine 15x and 4x because they are like terms that both have x. So I'm going to go ahead and do that. 15x minus 4x is 11x. So to combine the variables, I'm going to choose to subtract 8x from both sides. This is negative 12 equals 3x. Then to get x by itself, we divide both sides by 3. We get negative 4 equals x. Okay, number 3. I'm going to choose to go ahead and distribute the 6 to both of these and get 6x plus 18 equals 6x. Then I need to combine the variables, so I'll subtract 6x from both sides. That cancels that out. Oh, it also cancels that out. So all I have left on this side is 18, and 6x minus 6x on this side is 0. As you may know, this is untrue. 18 does not equal 0. Now, believe it or not, we've not made any mistakes here. This is an answer we should arrive at. It's something that's untrue. And what that tells us, when the variables disappear and the result is not a true statement, is that we have no solution. There is nothing, there is no number you could imagine that would ever work when you plug it in for x. There's no way to make these two sides equal to each other. So there's no solution. Now, a short way you can write no solution if you want to is write a 0 or a capital O, then put a diagonal line through it. So you don't have to put both of these. You can put either of these as your answer for a no solution. So when the variables disappear and you end up with a false statement, the answer is no solution. Number 4, we need to add 2x to both sides to combine these variables. Negative 5x plus 2x is negative 3x. And then we'll divide both sides by negative 3. We get x equals negative 3 for our answer. Okay, number 5. I'm going to distribute this over on the right side. So just rewrite this part. Negative 2 times 4x is negative 8x. Negative 2 times 5 is negative 10. We need to combine the variables. So let's add 8x to both sides. We're adding because these are a negative 8x. So to undo it or cancel it out, we got to add 8x. And that actually cancels out the x's on both sides, leaving us with just negative 10 equals negative 10. So this may feel similar to number 3 up here. It is similar in the fact that the variables disappear. However, this time we ended up with a true statement. We had to say no solution on number 3 because 18 does not equal 0. Not ever. But negative 10 does equal negative 10. So we have a true statement here. And what that means is this equation would work for any value of x you can imagine. So we can say, there's a couple of ways you can write it. You can say infinite solutions. I think that's what our book uses. Or you can say all real solutions or all real numbers. Or an even shorter way, if you draw 2 straight lines and then draw an R, that's the symbol for all real numbers. So any one of these answers would be acceptable. I would accept any one of these 3. You don't have to list all 3. You can just give me one of those. Okay, number 6. I'm going to add 3x to both sides because my first step is to combine the variables. It gives me 13x minus 5 equals 21. I add 5 to both sides. Then I divide both sides by 13. And 26 divided by 13 is 2. All right, back page. Remember, the thing I tend to do first is to combine the variables. So I'm going to add 5x to both sides. I have a negative 12x. Make sure you see that negative sign. Negative 12 plus 5 is negative 7x. Then we divide both sides by negative 7. We get x equals negative 2. Remember, a positive divided by a negative is a negative. When the signs are different, the answer is negative. When the signs are the same, the answer is positive. Okay, now just a reminder, when you see a variable by itself with no number in front, like that has a 3 or negative 3 in front, that had a negative 12 in front, that had a 5 or negative 5 in front, 4 in front, and so on. This has no number in front. Remember, what's understood for that to mean is that it is 1x. So I didn't bother writing it because it's just x. 1x means x. So you can do this either way. You can subtract 1x from both sides, or you can add 3x to both sides. Either way will work. I'm going to choose to add 3x. That gives me 19 equals 21 plus 4x. Then we subtract 21 from both sides. 19 minus 21 is negative 2. And my last step is to divide both sides by 4. Now, negative 2 divided by 4 is not a whole number. In fact, it's a number that's smaller than 1. But you can reduce that. So our answer is going to be a fraction, but we can reduce this fraction. Those are both even, so we can divide them both by 2 and get negative 1/2. Or if you have negative 0.5, that's cool too. Okay, there's several ways we could start number 9. So like, I think it was number 2 on the front, we do have two like terms right here that we could combine. We could say negative 3x plus 4x is 1x and just write 1x minus 6. That'd be completely cool. You could also add the 3x over and subtract the 4x over if you wanted to. When I see this problem, what I notice is there's a 4x right here and a 4x right here. So I can get rid of them both pretty quickly by just subtracting 4x from both sides. So that looks a lot simpler of a problem very quickly because I was able to just get rid of those 4x's. Then I'll add 6 to both sides. Divide both sides by negative 3, and I get that x equals negative 6. Okay, last 3 problems. I know there's words, but they actually won't take very long at all. So twice Beth's daily pay. So let's start there. I'll just use P for pay. Twice her pay, so 2 times her pay, is the same as equals her daily pay, P, increased by plus 45. So twice Beth's daily pay is the same as her daily pay plus 45. So find P, Beth's daily pay. So I gotta combine the variables first, so I'll subtract P from both sides. So remember, that's an understood 1P. So 2P minus 1P is 1P. And we find out that her daily pay is $45. So here I wanted to remind you again about checking your work if you're asked to do that or required to. We take our answer and we plug it back in the original equation. We replace all the p's we see with 45. So we do 2 times 45 equals 45 plus 45. So now we'll just simplify both sides and see if they equal. 2 times 45 is 90. 45 plus 45 is also 90. So it turns out we have a correct answer. Number 11, a number, I'll just call it n, decreased by 12 minus 12 is the same as equals 3 times the number. If you want to write 3 dot n for 3 times n, you can, but don't have to. So to find the number, we want to start by combining the variables. So I would subtract 1n from both sides. That gives us negative 12 equals 2n. Then we divide both sides by 2. Get negative 6 equals n. And to check our work, we just take this negative 6 and plug it back in the original equation. So I'd say 1 times negative 6 minus 12 equals 3 times negative 6. Negative 6 minus 12 is negative 18. 3 times negative 6 is also negative 18. Last one. The temperature, which I'll call T, increased by 65 plus 65 is the same as equals 5 times the temperature, so 5 times T, decreased by minus 15. Okay, so we need them to have the same, we need to combine the variables. You can go either direction. I'm going to subtract T from both sides. Gives me 65 equals 4T minus 15. Because remember, that's 5T minus 1T. Then we'll add 15 to both sides. We get 80 equals 4T. We divide both sides by 4. 80 divided by 4 is 20. So we find the temperature, try that again. Temperature is 20, so we find that T equals 20 degrees.